I know a lot of you have been working on this, and this is the simple way. The simple way of doing problem number 4 and problem number 5 on the chapter 5 test. Okay? I'll repost this tonight. Alright, so the one thing you got to know about in-center is you have to know the rules of the game. What's the rules of a game? To find the in-center P point is to find the angle bisectors. Okay? I have to find the angle, that means I'm bisecting this angle in half. I'm cutting it in half. That means this side is congruent to this side. Okay? Now, with that said, I'm going to do the same thing. I'm going to cut this in half. Right? And that's going to be congruent to this. Okay? And so then, when I cut B in half, it should match up. What this is saying is that these two are congruent. They are not congruent to this. They are congruent to each other though. Okay? So right away, alright, if I'm giving some information and I'm given XCP is equal to 26. So XCP, well X, right, X is created by this, and that's what we also have to understand, okay, is the in-center, right, the circle that's created inside is created from this P, and it's got to create points that are perpendicular to the sides. So it doesn't cut the sides in half, right? It just creates these things called the radius of a circle. And the radius of the circle is always equal to itself, right? And so this perpendicular tangent line, these are tangent lines because they touch the circle at one spot, okay? This circle is inside, okay? But we don't really need to know about this circle, okay? The only thing we need to know about this circle is that X to P, Y to P, and Z to P are all congruent. But it doesn't ask us that. It's talking about angles. Right? Jeremiah, why are you on your phone? Open your book. It's the last time I'm telling you. Alright? Now, the circle, the in-center, it's something that we're going to get to in the future when we come back to SOHCAHTOA, okay? But right now, we're just going to worry about what is the in-center. How do we make it? Angle bisectors, okay? These angle bisectors tell me that all these angles are cut in half. Now, if they tell me that XCP is 26, right? Well, that means from XC to P. Now, what's that saying is this angle right here is 26. Okay? And because this angle right here is cut in half, this angle has to be 26, right? So that means that if XCP is equal to 26, then YCP is equal to 26. Okay? And that's the definition of an angle bisector, right? Which also is given, and the other reason we know that that's true is because it's the definition of an incenter, right? So there's a lot of reasons how we can say those two are 26. Now, XCY or ACB, right, would equal 26 plus 26, right? So then, 26 plus 26 equals 52, which would equal, and is that any of these? BCA? ACB? Right? So that means that this one is 52, right? Why? It comes back to definition of not the incenter in this case. This case is more because they're bisectors. Because those angles were bisected, right? But in this case, it's substitution, right? We know that these two angles add up to be the big angle, right? So we can use angle addition postulate, right? We can say that XCP plus YCP is equal to, and then we want to use which one we're looking for, BCA, right? By what? Angle addition postulate. Okay? And then we use substitution, right? 26 plus 26 equals to 52. Okay?
That's 56.
Sorry. 52. Am I going too fast? Okay, let me slow down. Okay? So that's how we go about getting that first part. Okay? The first piece is just looking at, I know that these two are going to add up to be this whole piece, right? Which is 52. That's all I'm saying. Does that make sense?
It wasn't too bad.
Right?
What's the angle plus what?
The angles?
No, that angle.
26 plus 26?
No, right there.
This?
No, right there. Over there, that way. That.
Angle addition postulate. Angle plus pos. So it's just, remember that segment addition postulate from chapter 1? We also had that angle addition. Remember, we have two angles, right, formed to be one angle. That's it. Okay? Now, that's just from the XCP. What else did it give us? So let's use another color. What else did it give us? Try to use a color that we didn't use. It said BAC is 10. So it says BAC equals 10. Where's BAC? BAC. BAC. That means this whole piece is 10. So how much are these pieces? 5. Like, we already know that, right? We just know that, right? But that's what we're going to choose to figure out. Okay? And we got to look and see which one are these. Right? So BCA. BCA. Well, that one we actually already figured. BCA. That doesn't say BCA twice, does it? BCP. BCP. There we go. And that one probably has to do with this guy, right? No. BCP. Really? BCP? That says 26. We already found that out up there. We already said that. Okay. We called it YCP, right? But that's the same as BCP, correct?
Yeah.
So those are equal, okay? So ABC. ABC. Okay. Here's the thing. To be able to find ABC, right? I have to know something. I don't need to know that these are 5, but I could figure that out if they ask me. Does that make sense? So on the test, if they ask you, they tell you this is 10, you know how to tell me that each one's 5, right? This angle plus that angle is equal to this angle, just like this, right? And then substitute it in. Does that make sense? Right? We know that these are equal. We know that's 10. That means this plus this is 10. That means 2 of these is 10. That means one of them is 5. Right? But that's not what this one's asking us. This one's asking us, what is this angle over here? Well, we know that this angle is 10 and we know that this angle is 52. Okay? How much does all the angles add up to be? 180. So we know that 10 plus 52 plus angle ABC equals 180. Does that make sense? What rule is that? The sum of the angles in a triangle, right? The sum of the angles in a triangle are 180, right? We learned that rule way back in the beginning. Okay? And so now we just add these up. So that's 62 plus the angle ABC equals 180. And that is simplify, right? And then let's subtract 62. Subtract 62. And we get angle ABC is equal to 180 minus 60 is 120. And 120 minus 2 is 118, right? So we got 118, okay? Subtraction property of equality, and it's 118. And there it is. And we just solved everything, right? A little bit easier, I think, than the last time. I hope. I'm praying. Questions on that one? Does that seem easier now?
A little bit.
A little bit. Tiny bit. A little bit. Like that's how much I love you, right? That's what I used to tell my kids. That's how much I love you. Just that little tiny bit.
Why?
Huh? Because I don't love them that little tiny bit. I love them from right here all the way around the universe and back to here. That's how much I don't love them right in there.
Oh.
See? It's called life, right? It's all about the pinch of love that you can't give.